45 मिनट का लेक्चर 10:15 तो हो गया ऑलमोस्ट, चलेगा ठीक है, चालू करें इसको डायरेक्टली ना। ठीक है चलो, ओके थैंक यू। Good morning friends, again start with the same where we have last leave, and basically we have to start with the derivative of a sum, how to do provide the derivative of sum and differences. So yesterday we have seen the formula for the derivative, how we'll do the derivation of in the summation. So what happened, we have to apply the multiplication, just like ddx of fx. We can see over here, the when you found any an equation which is in plus or minus form, sum or difference form, so that time we have to use derivation of multiplier with the addition summation. My window is just like ddx of fx plus ddx of gx, and we have to again do the derivative just like this. This is the formula, and we use that formula here in this equation. How we'll solve this derivative? So here we have to apply like ddx of x square plus 2x minus 3. So let's start. So we have to take ddx of x square, then ddx of 2x minus ddx of 3. So x square, as we know the formula, x to power ddx of x to power n, which is nothing but n x power n minus 1. So the same formula we will apply it over here for ddx of x square. So what happened, 2 will come over here, so x to the power 2 minus 1, which is nothing but 1. So x to the power 1 is x. So ddx of x square is nothing but ddx of x square is nothing but 2x. Then we can use the ddx of 2x. Then ddx of 2x is nothing but 2, and the ddx of 3, which is constant, so its value is 0. So total value of ddx, so now the value becomes 2x plus 2, the final value, and the minus 0. So minus 0 we have to eliminate over from here. So final value will come 2x plus 2, which is, we can also write like 2, we will take 2 common, so it's become x plus 1. So derivative of x square is done by the power of rule 2, which we have seen. The derivative of 2x is done by rule 3, and the power rule and the derivative of 3, which is constant. We have seen the formula in the next previous examples. So more examples, just the ddx of root x. Root x is nothing but x to the power 2. So how will define the root x, which is x to the power 1 by 2? X to the power 1 by 2. When you find under root x, which is nothing but the power of that particular value 1 by 2. So we will start that ddx of root x is nothing but ddx of x to the power 1 by 2. So we can write that when you apply the formula number 2, so what you need to do, so 1 by 2 will come over here, so it becomes x to the power 1 by 2 minus 1. ddx of 1 by 2 x to the power 1 by 2 minus 1, which is nothing but 1 by 2 x to the power minus 1 by 2. You can find over here 1 by 2 x to the power minus 1 by 2. So this is x to the power 1 by 2. We can solve 1 upon 2 x to the power 1 by 2, because it is minus. When you come to denominator, it become 1 by 2. It is a numerator, so 1 x to the power minus 1 by 2. When this value come to denominator, it become plus 1 by 2. Or these things we can write like 2 root x, because x to the power 1 by 2 is nothing but root x. So 1 upon 2 root x. This is the way we can solve these questions. Then again find the value of 1 upon x square. Now we have to find the ddx of 1 by x square. How to solve this? So for this we can write that if x to the power 1 upon x to the power 2, when it is going to numerator, so it becomes x to the power 1 by 2, sorry, x to the power minus 2, like that, x to the power minus 2. So we have to solve the value of ddx of x to the power minus 2. So when we are going to solve ddx of x to the power minus 2, it is written like that, equal to minus 2, which is minus 2 over here, it will come over here, so x to the power minus 2, again minus 1. So it will become minus 3. So minus 2x x to the power minus 3, or we can write that minus 2, this is when you're going to denominator, it becomes plus 3, so it becomes x to the power 3. So it is very simple. One of the simplest example we have taken over here. It is very much simple, I can say that. Then we need to solve this question. ddx of 4x cube minus 2x plus 7. So what we need to do, we need to solve this, we need to find the differentiation of this value. So how you will solve this value, 4x cube minus 2x plus 7 by x? What we need to do here, first of all, we will bifurcate this value into 3 different parts. So what happened, x is everywhere. So what we will do, we will divide the x with each and every value. So 4x cube by x minus 2x by x plus 7 by x. So which is nothing but 4x square. When you're going to cut x by 3, so it becomes x square. It becomes minus 2, it becomes x to the power 7, x to the power minus, because in the numerator is plus 1. When it's going in the denominator is plus 1, when you go to numerator is become minus 1. The same logic what we have applied in the previous over here. You can see that when it is become x to the power minus 2, but it become in the going to numerator it become minus 2. The same thing we can see over here. So x to the power plus 1, it is over here, when it is going to numerator it become minus 1. So for this, when we are going to differentiation of this, so ddx of 4x square minus 2 plus 7x to the power minus 1. So what we need to do, we need to apply the formula over here what we have seen. This is the formula. The same formula we need to apply it over there. So it become like, so now we have to apply the same formula over here. So ddx of 4x square minus 2 plus 7x to the power minus 1. So like that, so we have to apply ddx of 4x square minus ddx of 2, which is nothing but 2, plus ddx of 7x to the power minus 1. Over here we can see that. So what happened, when you're going to apply ddx of 4x square, then it is 4 into 2 x to the power minus 1, sorry, 2 minus 1. So when you're going to apply 2 minus 1, which is nothing but x, so 4 into 2x minus ddx of 2, which is 0. Then ddx of 7 x power 7 into minus 1 will come over here, x power minus 1, again minus 1. So it is become minus 2. So this is obsolete. So 4 into 2, 8x minus, because this is the minus, so plus minus minus 7 x power minus 1 and minus 1 minus 2. So final value is 8x. See, it is in numerator is minus 2, when you're going denominator it become plus. So 1 upon 7 by x square. So this is the way we have to solve all the differentiation. It is very easy, not very tough. So you can easily solve these type of questions. Now moving ahead. And now this is we have to find the slope and the equation of a tangent line using the curve y is equal to 2x square plus 1 at point 1 and 3. So first of all recall the derivative gives the slope of a tangent to the curve, so we will need to find the derivative and evaluate at x is equal to 1. To find the slope of the point, to write the equation of the tangent line using the point slope form. So here we can see that there is a 2 point, 1 and 3. So what we need to do, we need to put the 1 in this equation and we will get the value of m. M is nothing but slope. So we can see over here in the next. So you can see over here. So what we need to do, we need to do the differentiation of 2x square plus 1 and y. See, here we need to take differentiation of both the side, y as well as left as well as right side. So what we need to do, we need to do dy by dx, ddx of y and ddx of 2x square plus 1. So what we need to do, again dy by dx. So if we will going to solve, see this is again there is a formula because it's a plus and there is a two part. So we will applying the same formula what we have seen. One second. What we have seen over here. So this is the formula, same formula we need to apply it over there. So we are going to apply the same formula. So we are going to apply it over here, 2x square plus 1. So ddx of 2x square plus ddx of 1. ddx of 1 is nothing but it's a constant, so it's a 0. So ddx of 2x square, 2 into 2, x to the power 2 minus 1. So ddx of 1 is 0 because it's a constant. And we know that the constant differentiation of any constant is 0. So it becomes 0. So ddx of 2x square. So 2 into 2, x to the power 2 minus 1. So this is 4, x to the power 2 minus 1, which is nothing but x. 2 minus 1 is 1. So x to the power 1, which is nothing but x. So this is 2 into 2, 4x plus 0. So now evaluate the derivative of x is equal to 1. So what we need to do, we know that there is a point 1 and 3. When you got any point and you need to draw that point in any, I meant to say any graph. So there is two things in the graph. One is x-axis and one is y-axis. X-axis is always be the horizontal line and y-axis is always be the vertical line. So in the x-axis, the first point which you got, which is nothing but the x-axis point, and the second point which you got, which is nothing but the y-axis point. So this is the x-axis point, this is the y-axis point. Now you have to put this x and y into the formula to get the exact location. So when you're going to put 1 over here, this is the x. So when you're going to put 1 over here, so you will get, and when you're going to see, now evaluate the derivative at x is equal to 1. So to find the slope, we need to find the slope of 1 and 3. So when you're going to put, basically m is showing the slope. M is going to show the slope. So m, when x is equal to 1, so you need to put 4 into 1. 4 into 1 is nothing but 4. So it is 4. So m, which is slope, you got the 4. So now we have the slope of the tangent line at point 1 and 3, and we can write the equation of the line. Recall to write the equation of the line, start with the point slope, form the use of slope 4 and points 1 and 3. So there is a formula to find out the exact line. So formula is like y minus y1 mx minus x1. This is the formula which you need to remember or you need to recall each and every time when you need to find the slope. So y minus y1, so y is 3 and x is 1. So we will put x1 and y1 value from here. So this is x1 and this is y1. So y minus 3 and x minus 1. So this is like y minus 3 into 4x minus 4. This is m. M we have calculated already. We have calculated 4. See, m we have already calculated 4 from here. So we will put our value over here and we will solve. So the final value become y is equal to 4x minus 3. Again, this is the graph. Now we have to see the graph. So this is the graph, y is equal to x square plus 1. This is graph for your quadratic equation and this is graph for your linear equation. So now we have to solve this equation. Find all the x values where y is equal to x cube plus 2x square plus 1 has a horizontal tangent line. So what we need to do, we need to start from here. We need to take the derivative of this, which is x cube plus 2x square plus 1. So ddx of x cube is nothing but 3x square, then 4x, which is so each and every time we need to bifurcate plus 1. So now since the horizontal lines have a slope of 0, set the derivative equal to the 0 and solve the equation, solve the x. So this is, you got the form, I meant to say quadratic equation. Now you need to put x is equal to 0 and we need to solve the formula. So how you solve the formula, I will show you an example. So formula is like what the formula was there, 3x square plus 4x plus 1. So we need to take 3x square, 3x square plus 4x plus 1. plus 1 equal to 0. So we need to solve this formula. So what happened? We need to solve like that. When you have in the quadratic equation, when you're going to solve this equation, so first of all you need to apply the formula. See, this is kind of situation where a x square plus bx plus c, this is kind of formula, this is the same. So here what we need to do, here the value of b, we need to take LCM like that it is always be equal to like here a and c. So b is always equal to like a and c. So here what we need to do, here we need to apply the formula like, so see, 3x square plus 4x plus 1. So what we need to do, we need to apply the formula here, like we have to first multiply 3 and we need to take the LCM of 4 in the form of 3 and 1. So what we can do, 3 plus 1 is nothing but 4. You know that 3 plus 1 is nothing but 4. So what we can do, we can like put like 3x square, so 3x square plus, we can bifurcate 4x like 3x plus 1x, which is nothing but 4 plus 1. So we can solve like, we can write like this in the 4x, 3x plus 1x plus 1. So now what we need to do, we can take the, see, 3x square and plus 3x. So in this first one 3x is common, so we will take 3x out. So it, in the bracket it will come x plus 1, and in the another bracket when we take, then we take again plus 1 is common, so again over here it will come x plus 1. Now we can see here what I have taken, here 1 is common in both, in this 2. So 1 I have taken common, so x plus 1 has come. So now we can see that now x plus 1 is common in both the cases. So we will take x plus 1 and we will write what the remaining is, 3x plus 1. So 3x plus 1 is remaining. So x plus 1, when we will take x plus 1, so 3x plus 1 is remaining, so 3x plus 1. So now it becomes x plus 1. So x plus 1 plus 3x plus 1, this is the value. So we can see that the value is 3x plus 1 or x plus 1. So what they have done, again they have taken x plus 1 and 3x plus 1. So we can write like that, because these equal to 0. So we can take like, so 3x plus 1 is equal to 0. So 3x is equal to minus 1 and x is equal to minus 1 by 3. This is the value of x if I am going to take 3x plus 1 equal to 0. If I am going to take x plus 1 equal to 0, so it will give you the x is equal to minus 1. You can see that it is very simple, very much simple. So x is equal to minus 1 or x is equal to minus 1 by 3. There is a 2 formula. So you got 2 answers. So the x values where the function has horizontal tangent, x is equal to minus 1 and x is equal to minus 1 by 3. So you can see that the graph below shown, see, this is the line for x is equal to 1 and x is equal to minus 1 by 3 to the tangent line. So now we start with the geometric new chapter, which is called the arithmetic and geometric progression. So in the arithmetic and geometric progression, what is happening? In the arithmetic and geometric progression, what happened first? See, first we start with the arithmetic progression. What exactly the arithmetic progression? In the arithmetic progression, there is a series of number with the same difference, common difference, just like 1, 3, 5, 7. So we can see the difference between the two numbers is 2. Between 3 and 1 is 2, 5 and 3 is 2, 5 and 7 is 2. So like that. So this is the arithmetic differentiation. Every time when you're writing the number, So difference between the two number has to be same. And in the geometric progression, it is same. The multiplier will be same. Just like here, I have taken the difference. There should be multiplied 2, 4, 8. So multiplier should be the same. So you can see that this is the arithmetic progression or arithmetic series, which is 1, 4, 7, 10, 13. So every time you find that the difference between the two numbers is 3 in the one. 4 minus 1 is 3, 7 minus 4 is 3, 10 minus 7 is 3. In the second one, again 1 minus 9 is minus 8, minus 7 is minus 7 into minus 1 minus 8, minus 15 and minus plus 7, so it becomes minus 8. So every time the difference is same. This is called arithmetic sequence. Add to the next. This is geometric sequence, which is 2, 4, 8, 16, 30. So every time 2 to the 4, 4 to the 8, 8 to the 16, 16, 32. So every time 2 to the power 2 is 4, 4 and 2 to the power 3 is 8. Every time it is multiplying. It is coming to the multiplying form. You can see that 9, 3, then 1 minus 1 by 3. So 1, 1 by 4, 1 by 16, 1 by 64, like that. So it is multiplying form. This is called geometric sequence. We are multiplying to get the next term. So the sum of these numbers, you can see that the first 35 is like 10 plus 1 plus 4, 14 plus 7, 12, 12 plus 10, 22, 22 plus 13, 35. So you can see that this is sum. And the same time you want to sum of geometric series. So you can see that 2, 4, 8, 8, 8, 16, 32, 32, 2, 4, 6, 6, 14, 14 is 60, 40, 30, 30 plus 32 is 62, like that. You need to add. So now we have to find, they have given you the question, find the next 4 term of this value, minus 9, minus 2, 5. So we need to first check the common difference. So when you're going to check the common difference, 5 minus 2. So 5 minus 2, which is plus. So 5, 7. So common difference is 7. You need to find C. So now the common difference is 7. So 7 is referred to the common difference. So every time you're going to add the 7 in the number, so you will get the next number. So 5 plus 7 is 12. Then 12 plus 7 is 19. Plus 19 plus 7 is 26. 26 plus 7 is 33, like that. You can see that 12, 19, 26 and 33. So find the next 4 numbers of the term. You can see that the common difference is 7. 4 minus 7, 14 minus 7 is 7. 7 minus 0 is 7. So you can see that the arithmetic sequence D is equal to 7. D is denotion of common difference. So D 7. So when you know the next 4 term, you can add 7 in the 14. Next 14 in the 14. Then you will get this. The same time, x is common difference. The next 4 terms is 4x, 5x, 6x, 7x. Here, the same thing, minus 6x. So you will get 13, 19, 25, 32. So vocabulary of sequences A1. Now we have to using the formulation. How you solve this? So A1 is equal to C. When you getting any series, so first term is first term. So 0 is first term over here. In the second, x is first term, minus 5k is first term. So we denote that first term is like A1, which is called first term. Then AN is nth term, which is last nth term, which they want to ask you. Then n is a number of terms. How many number of terms? Maybe 10, maybe 20, maybe 30. So n is number of terms. Sn is equal to sum of all the terms. We have seen that in the first example. See here, you can see that this is the sum. This is sum of the all term, which is denoted by Sn. So we can see that we have denoted that sum is through Sn. This is the Sn, sum of n terms. Then D is a common difference, what we have seen, which is already has been seen. So this is the formula. To formula the nth term, we want to know the nth term in the sense just like they have given you 5 terms. They have given you the first term. And they have given the number of common difference and gave you. So what they want the nth term. What they want 30th term. What is the 30th term? So with the help of this formula, you will get the 30th term. An is equal to A1 plus n minus 1 into D. So An is equal to nth term. A1 is first term. N is number of terms. D is the common difference. Then sum, if you want to take the sum of the arithmetic Sn term, which is Sn n by 2 a1 plus a1 an. So before I want to say you here, before going to the sum of nth term, you need to first know the nth term of the arithmetic sequence. Before sum, you have to know the nth term. So here we can see that they have given you the a15 is equal to 38, d is equal to minus 3. What they want to a1 in the first term. So in the formula is an is equal to n plus 1 minus an is equal to a1 plus n minus 1 into d. So a1 you don't know, so let the a1 will be x. Suppose a1 will be x. This is the formula total. So a15 n they have given you 15 here, and then an they have given you 38. Now d is minus 3. Sn you don't know, d is minus 3. So you need to find out a1. So formula is an is equal to n plus 1 minus into d. So we will put all the numbers over here. So 38 is equal to a1, we will let the a1 will be x. So 15 minus 1 into minus 3. So a1 is x is equal to 80. So a1 first term become 80. This is the simplest one. You need to put each and every value over here, and with the help of that you will get the final value. What you want, what you need to be calculate, you will get that value. Now find x63. S63 you need to find the sum of 63th term. So what they have given, first term is 19. The common difference is minus 13 minus 19, which is nothing but 6. So common difference is 6, and n is 63. You know that n is given over there as 63, which is nth term 63. So you need to find out an and Sn. So first, before find out the Sn, we need to find out the an. So an is equal to a1 plus 1 and minus n into d. The formula is same. So we'll put the formula an, which don't know. A1 is equal to minus 19 by 16, 3 minus 1 into 6. So final value an is equal to 353. You will got the final value of an is equal to 353. Now we have to know about Sn. Sn is equal to n by 2 a1 plus an. So we will put the direct value 63 by 2 minus 19 plus, so Sn is equal to 110,521. This is the way we need to solve the questions. Now if a is equal to 16, if a1 is equal to 1.5, d is equal to 0.5, find the value of a16. So they have given you a1 1.5, d is equal to 0.5, n is equal to 16, and you need to find out the next term. So an is equal to a plus 1 minus 1 into d. So you put the values, you will get the value. An is equal to 633, a1 is equal to 9, d is equal to 24, find the n. So an is equal to n plus 1 minus 1 into d. Formula, you put the value of, you will easily get the value of n. This is the simplest way to solve the equation. The same thing, find out the d when a1 is equal to minus 6, a29 is equal to 20. So you put the value and you find the value. X is equal to 13 by 14. Now we start with the geometric progression. In the geometric progression, what happened? We need to apply the formula with the help of multiplication. Each and every time we need to multiply the things and we'll get the exact value. So you can see over here, a1 is equal to first term, the same thing what we have seen in the arithmetic progression. An is equal to nth term, n is equal to number of terms, Sn is equal to sum of r. See, there we have using the d is equal to common difference. Here we want common ratio. Common ratio, how will find the common ratio, we will check. The only difference with the common difference and common ratio, because it is using for multiplying the numbers, so that's why here a common ratio. There we are taking the difference of between the two numbers, that's why there is a common difference. So formula of nth term is equal to an is equal to a 1 r per power n minus 1, where r is a common ratio. For Sn is equal to a1 r per power n minus 1 upon r minus 1. This is the formula. So find the next three term of this value. So r, we need to find out the r. R is nothing but not arithmetic. So this is not the what is there written, 3 minus 2 versus 9 by 2 minus 3. This is not arithmetic. So we need to find the geometric progression. How you find the r? R is basically there what we are using. There we are using the common difference. So we are taking the difference of two numbers. So 3 minus 2 is 1, but 9 minus 2 minus 3 is not 1. So this is not the arithmetic progression they are asking. So what we need to do? So we need to divide 3 by 2 and 9 by 2 by 3. So every time you are getting 1.5. You can see the difference, ratio of 3 by 2 and 9 by 2 by 3 is 1.5. So this is a geometric progression because their ratio is same in every time. Either we are taking the value 9 by 2 by 3 or either we are taking the value of 3 by 2. Always ratio is 3.2, 3 by 2, which is nothing but 1.5. How will solve 3 by 9 by 2? I will show over here. So they have taken 9 by 2 by 3. 9 by 2 upon 3. 9 by 2 by 3. 9 by 2 by 3. How you solve this? So what we need to do here? So 9 by 2, then multiplied by 3 will go up. No. 9 by 2 by 3. So 9 by 2, 9 by 6. It will become 9 by 6. 9 by 6 is nothing but it become 9 into 3 over here. So it become 9 by 6. 9 by, it become 9 by 6. 9 by 6 nothing but 3 by 2. It's a 3 by 2. So this is the simplest way to solve the equation. This is 3 by 2. So every time it's coming, you can see that 3 by 2. So we have to multiply 3 by 2 with every term. So 9 by 2 into 3 by 2, then 9 by 2 into 3 by 2 into 3 by into 3 by 2, then 3 first in initially one time, then again 2 times, then again 3 times. So you will get the value. Or what you can do when you apply the 9 into first time, then you again this you have to calculate this, and you have to multiply 3 by 2. Then this is the value will come. Then again you have to multiply it with 3 by 2. So you will get the values. So you will get 2 minus 3, 9 by 2, 27 by 4, 81 by 8, and 243 by 16. This is the way. Here they have given you a is equal to 1 by 2, r is equal to 2 by 3. You need to find out the ninth term. Here, what we have done in the common difference, the same arithmetic progression, the same we have to apply over here. Method is different, formula is different, but the calculation will be there. So they have given you a1, 1 by 2, r is equal to 2 by 3. So an is nothing but a. So what they have given, a1 they have given you 1 by 2, r they have given you 2 by 3, an we need to find x, n is 9, sn you don't know, r is equal to 2 by 3 they have given you. So now we can apply the formula, an is equal to a 1 r per power n minus 1, r is to n minus 1. So an you don't know, x what will take x, the formula a1 is 1 by 2, r is 2 by 3, n is 9, so 9 minus 1 8. So x is equal to 2 by 8 upon 2 into 3 by 8, because you can see that 2 by 8, because 9 minus 1 is 8, 2 by 8 upon 3 by 8 into 2. So this is the value of x, which is first term, nth term. So nth term value is, this is the nth term value, which is nothing but we will cut from 2 to this cut, so it has become 2 to the power 7 and it is 3 to the power 8 exactly. So this is x is equal to 128 upon 6561. So find two geometric means between this minus 2 and 54. Geometric means. So how you find the mean between these two numbers? So what we have the first number is a 54 minus 2 and nth term is 54. That's it. We don't have anything. Nth term is 4 because there is a four, two geometric means. We need to find there is four term. 1, 2, 3, 4. There is four term because two geometric mean we need to find. So two values should be there. So total value should be 4. So now we need to find out the first. We need to we have an, and we have n. So first we need to find out the r. So an is equal to a1, r to the power n minus 1. So 54 minus 2, r is x to the power 4 minus 1. So 54 minus 2, so minus 27, which is, you're going to divide 54 by 2 is become 27. So x to the power 4 minus 1 is 3. So x to the power 3 is equal to minus 27. And you know that 27 is 3 to the power 3. 3 to the power 3 is nothing but a 27. So value of x is equal to minus 3. If you know that, if you don't, see what happened here. X to the power 3 is equal to minus 27. And how will you find the 27? 27 is nothing but, how you find the 27? 27 is nothing but 3 cross 3 cross 3. This is the 27. 3 into 3 into 3. So 3 to the power 3 become 27. So here what we have done, in place of 27 we put minus 3 to the power 3. Minus 3 to the power 3 we are going to put over here. Minus 3 to the power 3 we are going to put over here. So one second, I will take the big one. It's done very well. What we have taken, minus 3 to the power 3 we have taken over here. So when the minus 3 to the power is equal to x to the power 3, so x is equal to 3 because their power is same. When the power is same, so the value will become equal to. So x is equal to minus 3. So we have shown here over, so x is equal to directly to minus 3. So now the next sum is 2 multiplied the 2 minus 3 6. 6 you multiplied with again minus 3 which is 18. And again 18 you multiplied with 3 which is 24. So from so you find the geometric sequence from here. So next question, if a2 is equal to a2 minus a1, find a2 minus a4. If a1 is equal to minus 3 and r is equal to 2 by 3. So what they have given you a1. So minus 3 you know this is first term. R is equal to 2 by 3. So you can, since r is equal to 2 by 3, so you can multiply it. So it has become 3 minus 2 minus 4 by 3 minus 8 by 9. Every time you have to multiply it with 2 by 3. So now if a2 is second term which is minus 2 and 4 term is minus 8 by 9. So what you need to do, a2 minus 2 minus 8 by 9. So 8 minus 2 minus plus 8 by 9 which is nothing but minus 10 by 9. You will get the final value. One of the easiest questions. So find a9. So a first term is root 2 to 2 root 2 like that. So first term is a1 is equal to root 2 and n is equal to 9. N is equal to 9. You need to find of an. Some you don't know, ratio is 2 by root 2. 2 by root 2 is nothing but 2 root 2 by 2 which is nothing but 2 by root 2. Barabar. So what we have done, we have applied multiply root 2 both the sides. When you applied the root to both the sides, it will become 2 because root 2 into root 2 which is nothing but 2. So they have given you 2 over here. So 2 and 2 it is cancelled. So final value is root 2. So value of r, what happened over here? We have multiplied root 2 and just forget this. What we have done, we have multiplied root 2 both the sides. So what happened? Root 2 in root 2 is become 2. So 2 root 2 by 2, 2 and 2 cancels, it become root 2. So an, formula is an is equal to a1 r to power n minus 1. So now x, an is equal to x, what we have seen over here. a1 is equal to root 2, what we root 2, see, and r is equal to root 2 again. So root 2 the power 8 minus 1 which is, sorry, 9 minus 1 which is 8. So root 2 power, root 2 into root 2 power 8. So final value is 16 root 2. When you are going to multiply this root 2 into 8 times, so root 2 into root 2 only 2. So 2, 2, 2, 2 which is 16 and finally is root 2. So value of this is become 16 and this is root 2. So x is equal to 16 root 2 which is nothing but a final value. So a5 is equal to 32 root 2 and r is equal to minus root 2, find a2. Suppose here what they have given you, a5 fifth term they have given you 32 root 2 and r is minus root 2. So x, you need to find a1, which is nothing but x. Another term they have given 32 root 2, n is equal to 5, some you don't know, common ratio root 2. So what need to do, an is equal to a1 r power n minus 1. So we put the value an, you know 32 root 2, x, a1 you don't know x, so r you know root 2 minus root 2, and at 5 minus 1. So we'll put this value and we found the x. So x, 5 minus 1 is 4, you can see that root 2 5 minus 1 is 4. Then again, so x, so 32 root 2, which is nothing, this has become 4. So root 2 into root 2, root 2 into root 2 4 times, 2 and 2 4. So 4x become, so we will multiply 4 8 is 32. So 8 root 2 is final value. X is equal to 8 root 2. Insert one geometric mean between 1 by 4 and 4. Denote trick question. So 1 by 4 into 4 we need to put one geometric mean. So a1 is equal to 1 by 4, and at time you know 4, n is equal to 4, 3, 1 2 3 3. Sn you don't know, r is equal to, you need to find of r. So formula is same. You put the value 4, because you know an, you put the value r power n minus 3. So you find the r square is equal to, so 4 16, r is equal to 4, r is equal to 16, so r is equal to 4. So value of r is equal to 4. So 4 is 1 by 4, 1 4. So value become 1 by 4. When you, there is two value, r plus or minus both, because when you're taking something in root, so it will plus and minus both. So value become 1 by 4, 1 by 4, 1 and 4, 1 by 4 minus 1 into 4, because 4 we need to multiply over here. Find out the S7 term. So you know, have the first term, you have the n7, Sn you don't know, r you know. So 1 by 4 upon 1 by 2, which is nothing but 1 by 2. So Sn, S7 is nothing but Sn. So S7, you put the value a1 r to the power n minus 1 upon r minus 1. This is the formula. You directly need to put the value. You will get directly value 63 by 64. This is the simplest form. 1 by 2, 1 by 2 to the power 7 minus 1 upon 1 by 2, which is nothing but 63 by 64. Now we have last topic, which is nothing but differentiation and integration. We need to do this differentiation. What is the differentiation? Differentiation we have seen, this is nothing but a difference. We have seen the ddx. Now we need to go only for integration. So integration. So finite differentiation and integration. Forward differentiation we have seen, this is the formula. This is the formula of backward differentiation here. X plus delta x is here, x minus delta x is here, and two-step method we can see that from here. So solution, saturation vapor pressure ES in the minimum Hg as a function temperature T. This is given some example, forget that. Find forward, we need to find out the value when you putting the value over there and we get the value. So this is the integration, the area under the curve fx between x is equal to a and x is equal to b. So you need to find out the integration. Integration basically we will denote like this. There is one curve like this, a, b. A is a minimum value, b is maximum value. So you can see that a here and b here. So this is the minimum value and this is the maximum value. Fx, same what we denoting in differentiation and dx. The volume rate of flow q of water in a channel or through a pipe is the integral of the velocity and the increment area dA. So we need to find out the q is equal to v of dA, So this is, we have finished all the basic mathematics which is related with the I meant to say in management. Here you find out the lot of things. We have completed our basic mathematics, or almost your QT has done now. So we will meet next class with another chapter. Thank you very much.